So in this question, what we've got to do is a bit of a harder one. So prove that my mathematical induction that we get sine of n pi plus x is equal to minus 1 to the power of n lots of sine x. So again, we're going to show true for n is equal to 1. So substitute n is equal to 1 in there. We get pi plus x there. We get a minus 1 to the power of x. Now, we've got to remember that sine of pi plus x is in the third quadrant. So what are we saying here? In the third quadrant. So in the third quadrant, sine of pi plus theta there, in this case, would give you minus sine of theta, because it's going to be minus sine of whatever that angle is there, and that's a related angle, so it'd be minus sine of theta. So that'd be minus sine of x. Pi plus x gives us minus sine of x. Again, we're in that third quadrant, so we have to remember that. So that would be true. So it's all good. So assume that for n is equal to k, that sine of k pi plus x is equal to minus 1 to the power of k sine of x. So what we've got to look at there is prove it's true for n is equal to k plus 1. So we want to get down to minus 1 power of k plus 1 sine x. So we start with our left hand side of sine of k plus 1 times pi plus x. So we expand it out. We get k pi plus kx and plus a 1 times pi. So if we have a look at this one, what we want to do now is we're going to use the sine of a plus b rule, expand it out. So have a look at that expansion. And then, so we've expanded it out. Now we realise that sine of pi, sine of 180 is 0. So that makes that side nice. The minus 1 comes from cos of pi. So we can do that manipulation now. Minus 1 times the minus 1 power k gives us minus 1 to k plus 1 times sine x, and it's proved. It looks hard, but when we break it down, it's not too hard. It's a little bit simpler. A little bit simple, but you've got to remember what everything is equal to in that case. So we've got to be really careful with that. So have a look at that algebra. Again, it's about the manipulations and getting it down to what we want.